Assalamu alaikum. Uh, my name is Lincoln Khan Mohammad Akib, and my group partner name is Mohammad Ashikur Rahman. So our project ID is 431R, and our title is Students Learning Activity Detection System. And the project is supervised by Dr. Sharyar Wani. So our project is about a cheating detection system, and it's basically a student learning activity detection system where we have three modules which will have an attendance module which will uh, recognize the faces of students and then take automatically attendance. Then cheating detection, where it will detect the students who are cheating and not cheating. And the third module is distraction module, which will detect students who are in the classroom doesn't pay attention to the lectures. Yeah. So for the introduction, the students involvement in cheating is a very common case nowadays. In an examination hall, the authorities have to hire a lot of invigilators to guard the students from preventing them from cheating. But and but there is no established means which would detect students cheating during the examination. And also, uh, people cheat because the students cheat because there are students who doesn't pay attention to the lectures. So as a result, they look for other means to pass the course. So they eventually are left with only cheating during the examination. So this is our problem statement. As I said, there's no established means to prevent the cheating, and the act of cheating comes from students who had not studied earlier. Yeah. So and also during a classroom when teacher has to take attendance, it takes around 10 to 15 minutes, and which reduces the class time, which is also quite a hassle to update every time in off taking attendance offline. So the significance for our project is to be able to assist teachers in taking attendance and reducing the unproductive time. Students will be aware of such a system that would detect cheating, therefore they will reduce their intention to cheat during the examination in the future. Student will be more focused knowing that there's a system that would detect uh, that the students are not paying attention to the lectures. And our main goal is to provide a quality education that will increase because of our system, our learning activity direction. So objective is to be able to implement the face recognition part of the attendance module of our research, to be able to implement the model for cheating detection and optimize the model in such a manner that it will detect students who are cheating during the examination. And a third objective is that to implement the model for distraction detection and optimize the model in such a manner that it will detect students who are not focused during lectures. Our findings is that, okay, for our methodology. So how we'll do that? For our project, we are gonna adopt method with an algorithm called yellow and a darknet framework. So yellow is um, a neural network which has convolutional neural network, which uh, which is a good detection, which is a good for real-time object detection. And darknet is a framework which is in the base, which was made in the basis of yellow. So this is our methodology. First, we're going to train the video that is by our dataset. The dataset we collected by frame, um, we took some short videos that students were cheating, and the dataset were done by us, and we splitted those videos into frames, and then those frames were labeled, by label img. So these labels img were also this the images, the frames that we got after labeling, we split them into training and text, training and testing, which is called validation. So after we splitted them, then we trained the um, images into model. We had to configure first, this is the configuration file. We have to configure the EOL architecture, and before that we had to make the EOL environment, which I will show, which my partner will show you after describing the overview of the poster of our project. And this is the pre-trained convolution weights which we'll get after every 1,000 iterations of our model, and the final weight that we'll get is after 10,000 iterations. So this is our visualization results, that this is for the attendance model result. So this is me and this is my friend, and we used our model to attendance model to detect, you can see that there is id, I think, yes, so there is id of students. The wherever the student comes, the model detects the student's id and face. So this is my friend, his metric number, and this is me with my metric number, and our model can detect more than more than one face at a time. So there won't be a problem if a student doesn't have a camera, then he can use other person's camera or webcam. So the second one is distraction detection. So this is the distraction detection. Uh, we have two classes, one is focused and one is yeah, distracted. So you see the woman in the picture is looking right to her, and this might in a hypothetical situation, she might be talking to a friend or not focusing on the coursework or lecture. But the girl on the left, this one, has is focused, is, yeah, looking straight to the lecture. So uh, it's not readable, but the focus detection is 0.87, and the distracted is, yeah, the accuracy shows 77%. And this is the cheating detection model, where this is me, uh, the I'm not cheating, and I'm just giving my exam in the examination hall, and it shows that 99% detection rate that I'm not cheating. It shows not cheating. And the for my friend who is looking behind him during the examination hall, it will detect whenever the his body moves backwards or face moves, then the model will show that it is cheating. And the cheating detection rate is here 88%. So our findings is that the attendance model recognizes student face with metric number, as I showed in the visualization part. The cheating part is that cheating model that we got detects students who are cheating with a good. We got a good detection rate. So, and we can yeah, we can detect the students who are cheating both online and offline. Nowadays, it's a common case that we have online exams, so our models would be able to also detect uh, students who are cheating also in online and also in offline. So the distraction model also detects who are distracted, the students who are distracted during offline or online lectures. And one of the things that our model can be also used for the candidates, job candidates who has to give exam and online. So our model also can yeah, detect cheating, non-cheating. Yeah. So now we'll explain the coding part, implementation part.
Assalamu alaikum. My name is Mohammad Ashikur Rahman. So now I will go through the all the process we have applied for building our own data set and training the model. Uh, okay. So first we have recorded a video for making a data set. For example, this video, we have tried to emulate the environment, how the student will react when they are cheating or they are not cheating. After getting the video, there will be uh, after getting the video, we have split the videos into frames to make our own data sets. So we have used this Python script for splitting the video into frames. So after that, we have cleaned the data. Like there's some blurry image and some image that are not relevant. We have make our data set clean, and then we have proceed to labeling. For labeling image for our model, like YOLO, for example, we use this software. It's called label image. Here you can see that all the data set are labeled by this here. So we mark the area, like we say this thing is for example is like cheating. For example, we mark this, and there are option for what is the action this image is showing. So it's cheating, so we cheat, then it will be marked. Like this, we have labeled almost 2000 images, 1000 for cheating and 1000 for non-cheatings. So this is how we also label the image. uh, in the same way, we also label the image for the destruction one. Like we have this dataset from Kaggle. We have downloaded this dataset from Kaggle. Like this dataset showing that the actor or user of these images, like they're moving out, or they're uh, showing the things, showing how it might be cheating on, sorry, how they are not, they are focused or not. So you also labeled. So after labeling, you can see for each image there's a text file created. In this text file, it's the region of the region of the image is noted, and also the class, like which class it's representing. Okay, so same way our cheating non-cheating data, you can see that whether it's cheat, there's also a text file, like it's representing which class is in the first number, and then the coordination of the label box. So this is how we prepare our data set. This is how we prepare our data set. After that, we split the dataset for training and testing using this Python script. Like we split into 80% training data and 20% testing data. After preparing all the data, we make them according to our formats. Like for training in YOLO object detection model, or we have to make a certain format that the YOLO recognize. You can see from here we need to have the object names, like what are the object names, what are the path for the training and validate, and also like object, which are the action they are performing, cheating non-cheating, and the training, like the training data path, and also the valid data part. After that, uh, we as our processing power of our computer is too low, and it's not able to train the CNN model, so we use Google Collaboratory. So here we use like 16 GB of GPU, and 11 GB of RAMs. Okay, so I will go through all the process, like how we did train the model. So first, use the framework, darkening framework for the YOLO CNN. after that we have to build the environment. So this is the code for building the environment. We enable the preferred settings for training the model first. Then after that we downloaded the dataset. We have already upload the dataset to our Google Drive, because Google Colab is work fine with Google Drive. It's very easier. As our dataset is bigger, we just simply download the model easily using this code. And for example, as Google Colab has some limitation, like it's only run 11 hours. So as the model is building itself and it takes a lot of time, so to prevent the losing of our model, we save the model each time after maybe 1 or 2,000 iteration. And then it take more than 6 or 7 hours, then we save the model and then retain the model again, as we have limited resource. So we can use this code for downloading our previous model. For the first time, we will download the default YOLO models, which is not trained yet, like weights, uh, and train it. So when we download the data, we just do some unzipping the data, like set the directory. After that, this is the most important part here, like configuring the YOLO's cfg file. Cfg file is the main key horse to our model. So all the settings of our data set and other things are setted here. Like this here is the class. Like we have two class, one is cheating and non-cheatings. For class, we need to use the certain amount of filter. Like the formula for this is we have two class, and there's a default number 5. We have to add 2 to 5, it's 7, and then we have to multiply with 3, so then it's 21. And we set the maximum batches here 3000, but when we do the training, we set it as a 10,000, and here is 8,000, and the steps and 9,000. So after that, when we do this, we build the model. Sorry, we build the cfg file. After that, as I said, if we start from fresh, we download the YOLO default weight for training, and if we retain the model, we just download the previous build model. After everything set, we use this command to to train our model. Like we set our data path, and the previous models. Since then we let it run. After the model has a certain weights, we can save the training models to our Google Drive, and then we can download the test data and use the test data for train our using our training image. We can test our model, like what is the accuracy of it, and other things. So now I will in background, I will try to compile all the requirements, and I will show you how we test, because it takes a lot of time. I will pause the video and run again. I have run all the models and download all the requirement data. So you can see these are the output. Like I have built all the models. We also download the data set, unzipped it, and also downloaded the previous model. So let's train. So I have uploaded two photos. Like one is for cheatings. You can see this image is clearly seeing that we are cheating, looking behind and trying to see from another person. So this one showing like he's not cheating, like he's writing to his paper. So we will try to run these two photos. Like one photo is named as triple P. So let's test the model. Mm, okay, let's try triple P JPG. So let's run. Okay, so it's successfully predicted. that we have detection layer 82, 94, and 106, all are type 27. So you can see that our image is predicted in 89.92 milliseconds, and the cheating rate is 88%. Like in this image, it's our model did predict that the person in this image is cheating. So let's visualize the data. So you can see it's detecting the cheat as cheating, and it's after detecting, it's saving the data as prediction.jpg. Let's show our prediction.jpg image, and you can see it's cheating. Like, so let's try another one, another data which is not cheating, is cn2. Let's run. So you can see that it's also predicted in 89.43 milliseconds, and it's predicting things. The person here is not cheating, is 99% accurate. So since that our model can detect, still detect the non-cheating image very well, better than the cheating one. uh, so let's visualize. So it's non-cheating. So we can see that actually the weight we have founded, like the training model, as I mentioned earlier, like there's some limitation on the Google Colab, and we don't have a powerful PC for processing all the data, so we are still training. So this is the idea for cheating and non-cheating. So now I will also show you the prediction of focused and non-focused. So for our distraction model, I have changed the weight of our model, like distraction, and also the data set. So for example, for I have also uploaded the uh, testing image is AB4, and another one is FN1. So you can see one is focused, another one is distracted. So let's first try with the AB4. Let's run the model. Okay, you can see it's predicted in 90.23 millisecond, and the distraction rate is 77. So let's visualize the prediction image. Okay, so this is the prediction image, 77%. Okay, let's try with another one, is FN1. So here the prediction is in 80.67 millisecond. The focus rate is here 87%. Let's visualize the data. So you can see the data is here focused. So that was our training, that was our focused and non-focused model. So my friend Lincoln will talk about the attendance, or the attendance model, and he will also demonstrate the live video, like how our model is acting when we use webcam and live stream. Okay, thanks.
Hello, this is Lincoln again. So this is the attendance part where I will show you how our model detects the student. So this is the part where the camera webcam takes the pictures of the student, and one has to press the ID which I've already put. Then the second is here the images are trained. So there are two faces trained previously, that's mine and my group partner, and the third one is, this is the testing part. So I will just show you how it's tested. Um, yeah, so it's showing that 162.9365 36%. The lighting condition is quite bad. That's why uh, the confidence is quite low. Yeah, now it shows that is 1629365, which is my matic number. Okay. Hello, this is the part for testing the cheating part, where I would demonstrate that how our model uh, detects the student cheating live. So I've already set up the script. Here I've taken the configuration file, yellow configuration. This is the weight, the model, and the model that we trained, the weight, and this is the class name. So let's see. It takes a lot of power, so it's showing that I'm not cheating right now. The FPS is quite low, and that's why the camera is lagging. So if I turn around, see, I think it says cheating. If I am like uh, looking to someone or talking to someone during the examination, it will say that I'm cheating. So if I come back and then looking at the camera, then it will say that I'm not cheating. Yeah, and the accuracy is 0.9. It fluctuates to till 0.97, 96, 99. Yeah. Okay. So I had paused the video and made sure that the right files are the location of the distraction weight is here. So I have put it here, the configuration here, and I've changed the object names also, the distraction object names. So now I will run it and then check if the model works. So the YOLO is taking pictures. So it says that I'm focused, I'm looking straight to the lecture. Suppose something like this, I'm listening to the lecture, so I'm focused. The accuracy is 0.95%, sorry, 0.95, so which is 96% detection rate. So suppose I just move back and talk to my friends. uh, yeah, so something like this, so it will say that I'm distracted. Yeah. Okay, so this is it. I think you have enjoyed our little project. Actually, it's quite big. We have the video session is quite big because we have 3 different modules and we had to explain a lot about that. So sorry for any inconvenience. Thank you for listening and viewing our video. Thank you. Assalamu alaikum warahmatullahi wabarakatuh.